This is simulated results. This result shows that the gain at resonant frequency without stacking is 5.7 and with stacking is 5.9. When we do stacking, bandwidth can increase but gain remains the same. This is comparison between single patch and stacked patch. First parameter is frequency range. Frequency range is 8.4 to 8.5 gigahertz and stacked patch is 8.3 to 9.1 gigahertz. Bandwidth is 126 and megahertz and 799 megahertz without patch. This is conclusion, highlights of achievement. Simulated result shows that antenna covered the frequency range 8.3 to 9.1 gigahertz, and this antenna can be used for skin cancer detection application. The gain of the antenna is achieved the desired gain for the optimized antenna. This is references. Thank you.
Questions from the jury panel.
So when we increase bandwidth, then mathematically it is proven that when we increase bandwidth, gain decreases. But in my antenna, when we increase bandwidth, but gain remains same. When we increase bandwidth by stacking of patches, bandwidth can increase but gain remains same than as a single patch antenna.
Also, you said in your equation that when you increase the bandwidth, it will reduce. Main bandwidth product is constant. But now you are saying that without sacrificing the gain, you are able to increase the bandwidth.
Yes, sir, without.
What could be the reason?
Sir, without, it should be needed that the gain of the antenna is high. That's why when we do stacking of patches, the slots are cut in the shape of smiley. This shape shows that when we do stacking, bandwidth can increase, but gain remains constant.
Whether it is smiley or not, when you do stacking,
Yes.
bandwidth is affected.
Yes.
You know what happens when you increase the substrate thickness?
Yes.
What happens if you increase the substrate thickness? What happens to the bandwidth?
Bandwidth can increase.
Why?
Substrate thickness affected the bandwidth. It can increase.
Why it will not decrease? How you are sure that it will increase?
How many papers are there? So 14, there I check how many. Then after
Let's move on to the next presentation.
T.
Odu Prava.
Today in the 2 T
Afterwards.
after
Central antenna radiation
after I think
study using
prediction.
phase-based ECG
What about
analysis.
So they will be delivering talk after you. He will be delivering talk after you. So this will be after the more talk. Sir, I will check how many left. Okay. So list is with someone. List.
Good morning, everyone. Today I, Arun Lungwar, ME student of British Chandigarh, is going to present my paper based on cell phone antenna radiation impact, study using parallel-based ECG analysis. ECG stands for the electrocardiogram, which represents graphically the electrical activity of the heart. In my next slide, I discuss my objectives. My objectives are: first one is ECG signal and its parametric-based analysis linking to arrhythmia. Arrhythmias is nothing but the diseases related to the heart just because of any disorder in the heart. And the second one is the parametric-based analysis of heart exposed ECG signals. We are taking, we are analyzing ECG signal in two modes. First one is RF exposed mode. In RF exposed mode, we are using the radiation refrigerated 2G mode, and there will be a mode in without mobile. This will be called unexposed ECG signal. And the third one is we provide some quantitative electrocardiography analysis to study the effect of 3G and 2G mobile phone on the heart activity as well as on the HRV. HRV stands for the heart rate variability, which consists number of parameters. First one is the vagal, and the second one is sympathetic, and third one is the centrovagal balance. These parameters are simply related to the emotions and the conscious and the subconsciousness of the human being. If the consciousness and the emotions will change, then there will be a change in the vagal and there will be a change in the heart activity. And with the change in the heart activity abruptly, there will be a chance of an disorder and there will be a chance of an arrhythmia. And the last one is we analyze the change in the different parameter of ECG for different person consists of various waveforms of electrical signal of heart. These waveforms are P wave, QRS complex, C wave, and the U wave. These all waves combinedly make a electrocardiogram. Now this is the design methodology. First one is the study of ECG and the related arrhythmias, and the second one is the parametric classification of ECG signal. Parametric classification of ECG signals I discuss in my next slides. And the third one is the collection of experimental ECG data in our exposed and unexposed condition. The two conditions are exposed and unexposed condition I have already discussed in my previous slides. And the last one is the parametric analysis of our exposures. Now the novelty in my work. We collect with the help of the different volunteers, we collect our data, and each of the volunteers attended 10 minutes of the recording session consisting of 5 different exposure conditions of 2 minutes. We take 2 minute samples in each stage of an ideal without mobile, or we could say in unexposed ECG signal, and the other with the mobile on 3G and the 2G mode on both transmitting and receiving condition. From the figure, we could say we are taking ECG signal in 5 conditions. The first one is the ideal, and other one is the 2G transmission to the receiving, the 3G transmitter and 3G receiving. Data acquisition system. We are using in our lab BioPack MP150 software to analyze the ECG and to collect the ECG signal. With the help of 3-lead ECG, by attaching the 3 electrodes on the body of the human, and we take different parameters in different mode and check the effect for analyzing the radiation on the human heart. This is a tabular representation of slight variation in the vagal, which I will discuss in my next slide with the help of graph. From the graph, you could see that there will be a slight change in the graph of the vagal for female and the male. For female, we could see there will be a more affected, the vagal will be more affected for the 3G in receiving mode for female, but in the case of the male, the vagal will be affected in the 3G transmission. These are the further parameters. Okay, we could classify our ECG signal on the basis of these parameters. So we could say we could classify parametric classification of ECG signal with the help of these parameters, with the help of RR interval, HR interval, RH interval, PH interval, QRS complexes. These all are related to the ECG signal. And these are the further parameters on which we conclude our data, we conclude our result, and we conclude our result that if any variation is going on in the vagal, if any arrhythmia is taking place in the human being, then by checking the variation in same in these parameters, you could see that is there any existence of arrhythmia in the human being on the related to the heart. These are the conclusions of my presentation. The result showed variation in the vagal during RF exposure, and the data suggested that vagal activity may be contributing the hormone component. And most importantly, if any person uses the mobile for a long time, the HR will change and the heart rate will also change with the change in corresponding vagal. There will be a chance of bradycardia and tachycardia. Bradycardia and tachycardia is nothing but is basically a type of the arrhythmia. Bradycardia occurs when due to the RF exposure, there will be a slight change in the heart rate, or we could say if the heart rate will become low, and there will be a chance of bradycardia, and if the heart rate will increase abruptly, then there will be a chance of tachycardia in those persons because of the RF exposure. And the last and the most important, 3G vagal is affected more as compared to 2G vagal during oral transmission mode in case of male, as I will discuss in my previous slide. These are the future scopes. Second one is the future study with 4G. Use of the different samples are most important is here. We could map brain to heart with the help of the RF exposure if we study the effect of vagal and other parameters. These are the references. Thank you.
You have shown some measured results. Are there any simulated results?
These are the results directly I took that with the software, and we analyze on the we are studying the effect of these results on the variation in the interval, in the variation in the time distance to because each interval have an ideal value, have an ideal distance.
You say yes or no? You have
No sir, these only these results are.
Secondly, you have shown a picture of a person
Yes, sir.
for whom ECG was being taken. Do you prefer ECGs being taken in a sitting mode?
Yes sir, we are taking ECG in sitting mode,
That is not the conventional way.
but we are taking in ECG in sitting mode.
No, you are comparing with again conventional PQRS.
Actually, sir, we are basically right now we are basically trying to check the effect on vehicle. This is my main object. I am trying to check the main effect on vehicle.
Especially in the receiving mode when you are taking all this data, what is the effect of the ambient RF condition? Have we tried to look into it? Because the signal will be quite weak, and the ambient RF condition due to the various pulses in the vicinity will create problem. I don't know.
Thank you. To move on to the next paper, by this way, even to formula, two elements broadband, beam antenna for wireless.
Mine.
Like satellite.
For wireless connection. The main objective of a television is to design a multiple MIMO antenna for wireless connection. As you know, MIMO antenna is basically MIMO antenna which uses multi-part in transmission and reception, which gives high database time, and it also increases range and reliability in wireless connection without consuming extra frequency. So, my objective is to design a multiple MIMO antenna. So this is the proposed geometry of my broadband MIMO antenna, which is simulated on F4 substrate of thickness 1.6 mm and its percent is 4.4. Here is the antenna dimension parameters of my proposed antenna. So the geometry of my proposed antenna is there. It's of very simple structure. As you can see, it is consists of a circular ring which is connected to a slotted square with two axis part in the top there. And this ground there, it is a convergent ground plane is used. And also it generates co-resonant frequencies in personal communication systems, wired WiMAX and satellite communication band. And this MIMO antenna is optimized for suitable MIMO performances like low angular coordination, low mixture coupling, and high efficiency. And also it has acceptable gain and radiation efficiency. So before designing my proposed antenna, I use these two elements of the antenna is configured such a way that it is orthogonal or parallel to each other. Among these three configurations, this proposed antenna shows good mixture coupling and low angular coordination, and this also gives good peak gain and high efficiency. Here, it is while observing this S parameter, you can see this intervals of this antenna is for first band it is at 1.9 GHz, which is the PCS personal communication system band, and other two interval is isolated cells for second and third band. It is at 3.2 and 5.36 kHz, which is suitable for wide and wireless. And the last one is almost 6.08 to 7.18. It resembles to 6 to 7 GHz satellite communication band. This is the radiation characteristics of my proposed simulated antenna. Here you can see this proposed antenna shows omnidirectional and bidirectional radiation pattern. In this elevation and azimuthal direction. Here you see that this cross polarization radiation pattern is very less compared to the cross polarization for all four operating frequency bands. While considering the memory antenna, it is very important to calculate the isolation between the two antenna elements, which is calculated by the envelope coefficient coefficient, which can be derived from the S parameters using this formula. And it can be seen that this envelope coefficient, which is almost less than 0.01. Basically, the possible values of isolation coefficient is less than 0.5. And for all four operating frequency bands, this peak gain is highest peak gain is observed at 3.21. And it's also this radiation efficiency, which is found at 88 to 93% for all four operating frequency bands. Again, my proposed simulated this is the photograph of my dedicated antenna, and it is observed that while measuring the aspect it also almost matches the simulated result. But in some cases, there is some difference. Is found some differences between the simulated results and experimental results. It may be due to the fabrication imperfection or maybe due to the tolerance of the gravity of the material. And this immunity, it is main important is this visual coupling. Here it is shown that this for lower frequency band, typically this PCF band. Here this visual coupling is this visual coupling this measured results is almost matches the simulated results. But for this and for this high frequency band, this measured results give the data performance. It almost near to minus 20 dB. Actually, this visual coupling is almost it should be less than minus 15 dB. Here you can, in conclusion, here we use the monopole circular ring. This antenna, this is connected to a square shape, slotted structure, and is and we connected to our related care. And it is a quadrant antenna, and we found the visual coupling better than minus 13 dB, and envelope coefficient is lower than 0.017. It is higher than 88%, and it is also good stable radiation pattern. And this piece of scope only antenna is there. It can be within range for mobile communication, and also what can be done to reduce the size of the antenna, and also what can be done to inserting some decoupling structure in the antenna. This can reduce the visual coupling. So these are the references.
In your objectives, you were mentioning the low error rate, high capacity, etc.
Yes.
In this coverage of experimental results or simulated results, you do not talk of any error rate or capacity calculation.
This actually divided this.
Yes, since you mentioned it in the objectives, not in the parameters to be estimated later. You have not presented any results in that.
So you might actually either because of what objective and this introduction.
You have an expression for the another correlation
Yes.
in terms of S parameters. Say in this case, if S11 is 0, what happens to your correlation? You have some conservative. Anyway, how do you improve the isolation between the two antennas? Although you have given some idea, because right now the isolation is around 15 dB. That's not good enough. The minimum should be around 20 dB. So, any idea how to increase the isolation?
Actually, sir, there is some techniques to use some decoupling structure in the ground plane. So that using the decoupling structure, actually it is also known as plenty ground plane. Using the decoupling structure in the ground plane, this isolation can be increased. So recently, I found in some papers that by the process is isolation it can be improved using the decoupling structure in a ground plane.
What is the separation between the two antennas? What is the separation between the two antennas?
That is 10 mm. 10. Lambda is lambda by 10. Lambda 4 watt it is. Lambda by 10. Yes, 4 watt.
Thank you. Thank you, Mr. Boda. So we come to the next paper by Mr. Rajat Pai. Design of compact broadband rectangular microstrip patch antenna to defected power.
Good morning, all of you. I am Ajay Tiwari from University of Rajasthan, Jaipur. My topic is design for compact broadband rectangular microstrip based antenna with defected ground plane. Objectives.
Design of compact broadband rectangular microstrip patch antenna. In my sheet, the name is there at the 12. Is it not there in your sheet? Yes. I got it. I got the name from my sheet. It's number 12. Manisha.
Manisha is also missing.
The Manisha is absent, but here in my list, it's Ajay Tiwari's paper number 12. Is it some spillover from the illustrator?
Yes. Are you writing this?
Okay, please, let it come for everyone. Let it proceed, yes. Manisha was absent.
The objective of this work was to produce compact broadband antenna. The scope includes design and simulation of first case rectangular microstrip phase antenna with finite ground plane. In second case, rectangular phase antenna with defected ground plane. And the last third case, modified rectangular phase antenna with defected ground plane. First, design and simulation of rectangular microstrip phase antenna with finite ground plane. Design using glass FR4 substrate, relative permittivity 4.4, log strength 0.025, and height is 1.59 mm. And the size of page is compact 23 by 26 mm, and the field line of 7 mm into a 3 mm. The design optimization carried out by using a CST software. First result of variation of reflection coefficient with frequency for rectangular microstrip phase antenna. The simulation result indicate that antenna resonated 5.03 GHz. The impedance bandwidth clearly 10 MHz, 1.9%, and the gain is 1.2 dBi. This antenna is modified in step by converting finite ground plane into a defected ground plane. In case second, modification in ground plane. First, cut two slot size 15 point into a 13.5 mm. Strip width is 2 mm, and the slits 4 slits is 33 mm into a 0.5 mm. No change in a pitch dimension. The result of S1 and gain with frequency. First, S1 in a broadband impedance bandwidth 2.2 GHz to a 4.47 GHz, almost 69.63%. The gain is nearly at 2.2 dBi, and gain is improved considerably in comparison to that obtained in a previous case. And third, in case third, design analysis of modified rectangular phase antenna with defected ground plane. In the accessor, we further modify antenna with T-shaped slot slit in the upper part of the rectangular page to obtain further improvement the performance from the antenna. And two cuts having a size of 18 into 2 mm. The base side is retained as it's without any change reported in previous cases. The result of S1 parameter or reflection coefficient with frequency and a modified rectangular patch antenna with defective ground plane. The bandwidth is 2.7 gigahertz to 4.68 gigahertz, almost 76.97,
जिसको कितनी मिलेगी उसके बाद
and the gain is 2.4819 dBi.
सर ने मांगा है
The conclusion: this paper reports the design and performance of a modified rectangular page antenna with defective ground plane structures that provide broader impedance bandwidth, nearly 2.6003 GHz, and nearly flat gain in desired frequency range in comparison to conventional rectangular page antenna. The maximum gain for antenna is close to 2.84 dBi. The proposed antenna may be used to load modern wireless communication system, including lower band of wireless communication system. These are references.
Question from the jury.
Antenna with finite ground
Hey, what is the size of the ground plane? I just missed that one. And size
33 into a 33 mm.
and patch size.
Space size 23 into a 26 mm.
Okay, how do we say that it is a finite ground plane?
With respect to a phase size, that is in a not more than phase size. It's a compact.
Do the results differ with respect to the infinite ground plane? No.
You said HS. I could recommend you said that the results differ from infinite case. So then what do you call infinite ground plane? What are the same? I think you should have clarified that on this question anyway. Thank you very much. So the next paper is by Shomgud Manda. Is that there in the jury list? The paper same omega atom synthesis is there? Okay, then please. Listen on that.
Good morning, all and all. I am going to present my paper, Plan SM for omega atom synthesis. Before going to details of my paper, I'd like to say that metametals are playing a significant role in application in different fields of electromagnetics. And these metals are realized by making array of small essentials of different shapes, that is square SRR, circular SRR, omega atom SRR, different types of shapes are there. Omega SRR is one of the convenient models because of its advantages over other models. And still it has some challenges that we don't have any closed form formula available for calculating the permeability and permittivity of the SRR omega atom model. We have to go for a lengthy process of using NRW method for omega atom. And that follows first we have to simulate the omega atom, then we have to get the S current, the magnitude and phase, and from that we calculate the permeability and permittivity using the NRW method. So the objective of this work is to find a closed form formula for omega atom to find the permeability. So philosophy behind the work is that we know that dependency of the permeability and frequency follows the Lorentzian form for both SRR and omega atom. So from this you can conclude that both SRR and there is an equivalent model exists for omega atom of circular SRR because both of follow the same Lorentzian form. This is concluded that for H omega atom an equivalent SRR exists. So, and we know that Lorentzian form directly available for SRR by the dimension we can get the permeability of the SRR. So, if we can find an equivalent model of the omega atom as circular SRR, we can easily find the permeability from the equivalent model. What is the proposed method? In proposed method, we know that we have 4 design parameters for omega atom and we have 6 design parameters for circular SRR atom. In any way, you can find the equivalent six dimension of circular SR for an omega atom using some technique, then you can find the permeability of the omega atom easily from the map dimension. And for this we use the technique space mapping. So what is space mapping? Space mapping is based on two models, that is fine model and force model. Fine model is basically a costly model which gives us accurate output, whereas the force model is a less cost model which gives us approximated output. The objective is that we will adjust the force model so that we get the exact output from the fine model. How we make that? How we adjust the force model? We do some mapping technique. The mapping is based on the error obtained by the fine model and the force model. The inputs are mapped to another set of inputs which will give the exact output from the force model. That is same as the fine model. If this objective is achieved, then we can find the output with less cost model instead of using a costly model. So get the desired output of the mapping. And this was the exact what we take a omega atom dimension. From that dimension, we calculate the permeability from the fine model that I have explained as fine model. And then follows first we have to simulate in EM2. Then we get the S parameter and S parameter magnitude which is needed for putting in NRW method, which gives us the permeability. And this permeability is our desired value. And we take the calculate the mu from the fine model. That follows the mapping technique, and the mapping technique gives us the SRR equivalent SRR model from which we use the Lorentz from get the permeability, which is the approximated result. Then we calculate the error and adjust the weight of the mapping tool. Here we have used the mapping tool as a functional attribution neural network, that is an alternate model for multi-layer perceptron neural network. Why we have used plan? Plan has some major advantages. Plan has some major advantages that it does not need any hidden layer, so it is less complex compared to multi-layer perceptron network. Here you can see that there is no hidden layer, only input layer, then directly we find the output layer. And in plan we get the output faster than the compared to other models like multi-layer perceptron neural network. Here I have shown the MATLAB simulation, the code I have written for. You can see the error is continuously decreasing, and the rate curve, which is our force model output, is continuously coming towards the desired value, that is the black curve. And the black curve is obtained from the NRW method. You can see also that the weights are continuously changing with the decreasing error. And I have said that the plan has advantages for multi-layer perceptron that within 60 to 70 degrees of the network estimate. You can see after the network exchange, the error rate curve, and so the results. These results are taken for different learning parameters for functionally attribution neural network. The first figure shows the permeability curve extracted by the NRW method from the CST simulated data, and the next two figures shows the comparison between the fine model and the force model for different learning factors. The best result is obtained with the learning factor of 0.002. Here are the results using space mapping. These 4 dimensions of the omega atom is mapped to these 6 dimensions of the circular SRR, and using these 6 parameters. The red curve is obtained from that 6 parameters, and the black curve is obtained from the CST result using NRW method. So you can conclude that the map dimension is matched with the CST simulation result. So you can conclude that the mapping technique is achieved, and the important thing is that we get the result with less than 0.5 seconds. And if you use the conventional method, then we get the result with more than 20 minutes, because you have to simulate and then you have to design, simulate, get the parameters from the network. Future scope in future, I want to extend the work to calculate the permeability of the omega atom, because here I have considered the permeability.
Two things.
I think what you are trying to do is you have some omega geometric shape. You are trying to compare it with a
I don't want to compare.
not compare, but you are trying to put it in terms of equivalent split ring resonator. And you are trying to find out the equivalent parameters of the equivalent SRR parameters. Are these equivalent SRR parameters independent of frequency?
Yes, no, it is not independent of frequency, because I have shown you. These dimensions I got from the equivalent model.
Yeah.
Using this dimension, I have to put it in the Lorentzian form available to calculate the permeability. And that is the formula itself has a variation of the frequency. And for this Addition of frequency. Addition of frequency I get this call.
No, what I was trying to ask that you have an equivalent SRR, and from this equivalent SRR you calculate the permeability as a function of frequency and permittivity as a function of frequency. Do you get the same value as you are getting from simulation?
Yes.
Exactly.
Yes.
Okay. What's the percentage difference? What is the percentage difference?
Error.
Yeah. Do you think it is exactly equal? Is also permeability? Are they exactly equal?
The error is 0.05.
0.5% or what?
Numerical value is 0.05%.
I am interrupting. I think you are talking about the error in your area band, but what is it?
Which meaning we should minimize the error in the area so that this
No. Error in the end results are like permeability. I would like to know.
That's right.
Error.
I would like to ask. Sir, neural network always gives an approximate results. That's always there will be there are 5.5 for 4 to 5% will be error. So we get this permeability of near about approximate permeability. You can say that there is not near about matching is there.
You are saying it is approximate. What is the approximation? 5%, 10%?
Yeah, 5 to 6%. Error percentage 5 to 6%.
What is the value of the permeability which you have obtained? What is the actual value?
the actual value is minus 40 for the atom I have taken for dimension. For this dimension, the permeability is minus 40 at some particular frequency. And for the lab dimension, you can see the permeability is same.
Because when you are drawing a graph, you don't mention what is x-axis, you don't mention what is y-axis. That is not a proper way of representing the graph.
This is the permeability and permeability is axis and this is
You mean the relative permeability?
permeability obtained from the anatomy.
Is it relative permeability?
Yes.
You are
Yes, sir.
new.
Mu.
Any other question for you? Thank you. We move over to the next paper then. And you want to please somebody that please.
I want to reduce relative peak size of the we know that our main we know that our main power is considered by manual and central level it is a wastage of power in undesired direction. So we reduce the power. We want to increase our power in main view. So we want to reduce the relative peak size of the and similarly second fixed personal beamwidth. So increasing here and directly my design objective. Here we discuss two cases. In first case, we consider linear array of isometric antennas along y-axis. 30 here we discuss. Here we have taken 30 elements to find out the specified size of level of minus 25 dB and specified personal beamwidth of 10 dB to generate the free space for this bed. In vertical YZ, principal vertical YZ plane, In second case, we also consider 30 element linear array of isomorphic antennas along y-axis to generate pattern with which fits side lobe level minus 35 dB unless and specify first order limit of 8 dB unless. In this case, in first case we have taken inter-element spacing 0.5 lambda as a constant in all elements between all elements, and in second case inter-element spacing varied from 5 lambda, 0.8 lambda, and finally we selected a specified inter-element spacing to obtain our desired result. So for constructing vertical radiation pattern, the array factor is given by the following equation, where IN is the element number different wavelength, I is the excitation current amplitude of the element, and I is the measuring quantity based divided in space constant or wave number, and D is the element spacing. Theta is the polar angle which is measured from here is the road side from -90 to +90. Now, for optimization, we use quantum particle from optimization. Here, first one, we initialize the population of particles using a random uniform probability distribution function in between 0 and 1. Second one, defining the evaluation function of force function. Third, fitness value obtained by initial value of particles are set as a personal base of the particle, and the base value of all the p base value set as set as a g base or blue base of the particle. Now, fourth one, calculate the mean base position. It is of particle which is given by equation. It is find out by the equation. Now, it determines the current base fitness value in whole population. If the current base fitness value is better than the global base, then assign the current base fitness value to G base and assign its coordinates to G base coordinates. Determine the vector local focus of a particle using following equation. 7 point, we update our position by two equations which is given here. If in free dimensional I particle using following equation, where xid is the if xid is less than xd minimum, xd minimum is the position minimum position, and xd maximum is maximum position. So according to these two equations, according to these two conditions, we find out we update our position here. Now T is the where T is the current generation. Random 1, random 2, random 3, random 4, and random 5 are the uniform random number between 0 and 1. In last stage, repeats step 2, 7 until issue criteria is satisfied. Here in last slide we discussed P and P, where P is the vector of the focus. Here P is the local attractor of each particle, and alpha is the contraction and expansion coefficient of the particle, which controls the convergence speed of the particle. And in order to avoid premature conversion of the particle, mean base position is regarded as the direction of the particle. Now, the force function of the force function for both cases we discussed here, where K1 F1 is our first function and F2 is our second, where SLO and SLD is our desired and obtained value of side lobe level, where K1 and K2 is the weight or importance which is given here. For first case we have taken K1 equal to 1 and K2 equal to 3 for case 1, and for K1 K2 equal to 1 for case 2. Now, this is our desired and obtained result. In first case, we want to reduce our side lobe level minus 25 and 25 dB. At first limit, we want to fix at 10 dB, which uniform element spacing 0.5. The obtained results is in first case we obtained minus 25.10 and first limit is 10 dB. Where computational time is also given for 77.2 seconds. In second case, we want to achieve the desired side lobe level minus 35 dB and first limit of 8 dB, where uniform element spacing is very from 500.8 lambda. Now obtain the value of hydro level personal unit is minus 35.01 and personal unit is LTV. The desired after value of meter network is 0.7956.
Wind up with the time is over. Just wait.
Okay, this is the array pattern which we are generated by simulation. In first pattern to transfer by solid and here we say we show that the resonance is reduced there is reduced to 25 dB and in second year etc. are reduced to 35 dB. Quantum particle optimization, which algorithm is here used for synthesis of linear isotropic antenna to reduce the pitch size of error and fix the further memory. And the results obtained, desired and obtained results are very clearly made here. The main advantage of UPS is that it finds a suitable element spacing and current amplitude distribution to find out our obtained result. And second, that's what results obtained our use of linear isotropic and illustrated the performance of the UPS. The future is so there must be a large scope of performing ambient study on the element spacing, length of the antenna, and we will consider user working effects of the radio spectrum.
We have not shown the current distribution for the array. Okay. Secondly, when you set 25 dB side lobe level, don't you think you can? I've seen some studies claiming even 50 dB side lobe level. No, with the same number of elements. It's not possible.
How many elements is there?
How can you say that?
How can you say that?
If you want to reduce size of level more, so you want to get more elements.
Again, people have reported it. The reason is, the crux is that the sensitivity of the design increases as you want to go for the higher side lobe level with the same number of elements. So if there is a slight change in the current distribution, this side lobe level is going to change drastically.
There are other methods of synthesis also, in which the desired side lobe level can be achieved. How do you justify your method is going to be there in comparison with the existing synthesis methods?
So here we find a suitable element spacing. If we here we very element spacing for so here we obtain desired and actually we obtain desired spacing. Here we want to reduce minus 35 dB.
That's not the question. Question is there are other methods of achieving whatever is your objective. Why you are taking this method? We are not taking other methods which are already established. Why you are going for this?
Yeah, it takes us less time. Sir, I already saw
Have you tried with ESO? Because you are following parabolic paper. Have you tried this with ESO only? Not with ESO, not quantum. This is quantum case. Have you tried with ESO?
No.
Then how are you saying that this time is better than that? If you look at these papers, around these papers, the conclusion is says that QPSO takes more time than the PSO. Go back to his paper. Look at his conclusion. He says that QPSO, whatever he has, that is why you will not find a second paper by Saravani or anybody else in the projection. So only one paper in 2007 or 8. Yes, this one paper. Again, he admits that it takes more time than the normal PSO. How do you justify this to be better than that?
So here we obtain our desired results, and because we want to reduce the more.
Now you said that you took this work because it gives you less computing time. That was the answer to That's the question. That is what I said. Now, if you have read that paper, that says that it takes more time than PSO. It has other advantages. It gives other advantages, but you are not taking those advantages here.
If you increase the inter-element spacing from 1 up to 0.8 lambda nearly, what happens? You run from 0.5 to 0.8 lambda. Are there any problems linked with increase of inter-element spacing like that? No problem. You can increase it to any element.
If I increase more than 0.8 lambda to 1 lambda, so there is a problem of breaking of.
Is 0.8 lambda acceptable for your application? Just for curiosity sake, why don't you decrease the spacing? Why do you have run from lambda by 2 to higher side? Why not on the lower side? 0.45 lambda. Anyway, you are using isotropic method.
Okay, I think that's it. So thank you, Ms. Mutla. I think we were left with number 4, we are democracy calculator. So please compare to university located analysis, models is
Greetings, everyone. Very good morning. I am Deepanshu Sriya. I'm a student of BTech from Sharda University. Before going further, I go for a 1-minute preamble. Now,
Sir, you presentation on that.
Because of such a wide band, it is exposed to all otherwise like Wi-Fi, Wi-Max, etc. Now here I present a modification of the Bluetooth antenna with the triple notches. 2 notches have to be present for in Wi-Max bands and 1 in hyper. The objectives of a fixer are selective rejection of frequencies. Now, for rejection of frequencies, one can think of 3 approaches. Straightforward. First is filtering out those frequencies using microwave filters. Other could be designing a source pulse which does not have which has zero output spectrum and those frequencies. And the third one is what I have done to disturb the matching of the antenna and frequencies. Other secondary advantages that we get from this are frequency flexibility. Just by changing the dimension of the source that I read, we can have frequency move to other bands. We have multi-nodes within the same antenna, and thus that can be near. This antenna has been already once modified by me for data confidence for dual status in Wi-Fi and Wi-Fi. Now, the term I have used here is CSSRR, complementary single slit regression. And I have modified it to what acts as overlap complementary single slit regression. Now, for the having to modify this antenna, I make it a resonator so that we could get more characteristics. Now, for putting a resonator, the size is a restriction because this design is already been matched, and now I have to use to modify this one. Now, the Fourier waveguide has been used, and the matching has been done so to achieve a characteristic impedance dimensions are as well. The novelty in this design is that I propose a new structure called overlap CSSRRs. The major advantage is that the cavities created by the CSSRRs are actually used at two different frequencies within the same structure due to overlap. But it was observed that the frequencies at which resonance would take place or the notch is not a function entirely of the length of the resonance. I tried to figure out several other dependencies of that. One which I found when this graph is of this picture is of current density at 3.6 GHz. We see that a very high density of current is available at that point. So I tried to optimize parametrically this area to a certain length, which comes around 2.3 millimeter. And due to this restriction of dry etching to be able to fabricate it only at 2.5 millimeter, I do not have that. The picture shows the VSWR of the mass antenna without any source. And the next picture shows that three notches have been created where the S parameter goes above 10, hence causing antenna to not radiate at those frequencies. This is the same with the VSWR. The upper picture shows the VSWR of the original design, and this is after the modifications of the actual source. This is just to show that I have been of some dimensions. The analytical results here are this. The current surface current has been shown here in these three pictures of the scale. These three pictures show how the surface current gets distributed along this length, and we can clearly see that the longer the length, it goes in accordance to the frequency limitation. The longer the length, the resonates goes to the lower side of the frequency. 3.6 Ymax, 5 hyperlap, and 5.8 again Ymax. Conclusions. As I said, that the rejection of frequencies are achieved at these bands. This good resonating structure, overlap, CSSR, and three sharp notches with the flexibility that we can adjust to other frequencies. Right now, we do not have very high power applications in the power element antennas. So within a few years, we will be having that, so we will be able to fabricate embedded with the lab options.
Question number 3.
You said that you are not using any filter.
I said there could be three obvious approaches for filtering of frequency. One could be designing a source bus which does not have PSC of is in value, very zero. Or we can have a microwave filter related to figure out those frequencies which we want to reject. Or we can go for an antenna which does not radiate at this frequency or receives at this frequency at all.
Any more question on it? Okay. So thank you, Mr. Chair. And in fact, we are coming to the end of this session. I'd just like to call once again Ms. Monisha Guleria. She was absent because her name was called. In case she was not. No? She can mark her absent, and once again I declare the session to be over. Thanks to everybody, the presenters for the high presentation, the jury for very, very meaningful interaction, and my co-chair and audience, everybody. Thank you. Thank you, and session is over.
Thank you, Master Sir. Now we are moving towards our next section. The inviting talk from Professor S. Raghavan, who is a professor in electronics and communication engineering at IIT. And for this session, I would like to request Professor Rao to please chair this session. Professor Rao. Professor Rao, sir, I only request please chair this session. This is an inviting talk on magic of lambda by Professor S. Rao. So now before this, I would like to introduce Dr. S. Raghavan. I think no introduction is required, but still formality has to be done. Sir is so much experience and having so much publications, books, numbers, means what to read and what to skip. This is what I am seeing from his profile. Dr. S. Raghavan is a professor in Department of Electronics and Communication Engineering in IIT. He has a specialization in microwave engineering, microwave integrated circuits, and he has won so many awards, QIP fellowship for PhD, publications in international journals, scientifically explored, national, international conferences, and so many projects he has also handled and successfully completed. Professional society memberships he is also having. So we are lucky to have Professor Raghavan. So I request the consent of Professor Rao. So over to Professor Rao.
I invite Professor Raghavan, our managing chair of this
Actually, I went to a different page.